Hello friends, welcome to JavaFx 3D tutorial. Now we are at the final part of the subseries JavaFx transformation. So in this video we will see how to combine transformation to produce a net effect on the transformation. We can apply more than one transformation to JavaFx shapes. So in all our previous video, we saw translate or rotate or scale transformation. In this video, we will see how to mix more than one transformation to JavaFx shapes. One way is create n number of transformation via translate, scale, rotate classes and then add them to the get transforms list. So we know that get transforms will give back a list of transform collection, and to that transform collection you can add these translate, scale, rotate transformation. Then when JavaFX scene graph is read by the FX runtime, it will apply the transformation one by one. The other way is creating the transform object and appending the transformation one by one via the call to createConcatenation method. So using the createConcatenation method, you can append the transformation. Say for example, if you created a transformation 1, so you can create a transform object, then make a call to createConcatenation and add the transformation one by one to the transform object. Then we can add this transform object to the scene graph, so JavaFX knows how many transformation is applicable for the object. In this video, we will rotate a box 20 degrees in x-axis first and then 45 degrees in y-axis. So in one of our previous video, we saw a rotation of 40 degrees in all XYZ, right? So we created a 3D point and we told that rotate the object 40 degrees in all three axes. But here, if you see, we are specifying different degree on each axis. So in x-axis, we want to rotate the object 20 degrees. And in y-axis 45 degree, and in z-axis if you want you can rotate it to 60 degree or some other degree. So not only that, here in this video we are just taking rotation as the transformation, and we create transformation 1 and transformation 2, and when we go to demo, if needed, we will add one more transformation. So here we are taking only the rotation, but you can even create some other transformation like translate, scale as well, and you can add that to the transform using the createConcatenation method. And you can add them to the transform object using the createConcatenation method. Here, if you see, we create a box with a dimension. We apply a Wang material to supply the color. Here we are supplying the khaki color, and we are adding the box to our scene graph. So initially, the object will look like this. Next, we create a rotate transform object. So new rotate, and this is a transform object T. Instead of rotate, you can even use a transform. After the transform object, if you see, we create a rotation RT1. We already know about this rotation class, and we set axis as x-axis. Then we are setting the angle as 20 degree. Then to this transform object, we are making call to create concatenation, and we supply our rotate RT1 here. So this way we supply the first transformation to our transform, and this will rotate the object in x-axis 20 degree. Next we create one more rotate, and this time we specify z-axis, and angle is 35 degree, and we are concatenating that to our transform object here. And this will make rotation about z-axis, which is 35 degree. So we already rotated this in x-axis, so this is the x-axis, and you can see the top face, which is not visible, is visible now. Then we rotated this in z-axis direction, and if you see, this is x, we already rotated it, y, and in z-axis we are rotating it now. So z is pointing towards you, and the angle is 35 degree here. Finally, we create our third rotation, rotate RT3. This is our third transformation, and this time we specify axis as y-axis, and we rotate it by 45 degree, and we are concatenating this rotation also to our transform object. So the transform object now contains 3 rotation object, T1, RT1. So all these are chained to this T, and here you can see this time the object is rotated about y-axis as well, and that's how you are seeing the other face. So finally, to our root, we make call to get transform and add our transformation T. Here, if you see the transformation, none of the transformation here is linked to a specific object. So here we created the box, but the transformation is not linked to the box. So it will perform this transformation to the entire scene, and since our scene contains only the box will get rotated by this transformation concatenation. Now let's go to the demo and implement this code change. We will copy our previous example and perform a refactor paste. So now we will clear out the start method call. Here we first set up the camera, and we already know about the camera. In one of our previous video, we talked about a perspective camera. So stack pane, creating the scene with a specific size. And here we are setting up the perspective camera, and we are linking that to the scene using the set scene, set camera method. Next, we create a transform object and 3 rotation. So since this was already explained, we create a box, assign a Pong material, then we add the box to the scene graph. Then we create a transform, rotate a transformation, and then we create a 3 separate rotate, and we give that to our root. So the root here is stack pen. So if you see here, root.get transform. So for the stack pen, we are getting the transformation, and we are adding all these transformation. So the transformation is applied to the container itself. So here the container is stack pen. So whatever it contains, all those stuff undergo the transformation. And transformation here is not single. And if you see, this transformation T is concatenated with 3 other transformation. So now if we run this, you can see the box will get rotated in all 3 axes. So that's all here in this video. So in one of our previous video, we rotated the box with equal axis, with the equal degree of rotation in all 3 axes. But here we rotated the object with a different axis, with a different angle of rotation. The x-axis we rotated it 20 degree, and in z-axis 35 and y-axis 25. So we changed the axis of rotation. So here in the scale transformation, we did rotation, and this is a different, this is a 0.3D. We asked to rotate the box in all 3 axes, and in all 3 axes it takes the equal degree of rotation. But here using the concatenation, we rotated the object with different orientation in all the axes. So this transformation will be useful to animate the object, and that we will see in the next sub-series. That's all here in this video. Thank you for watching. Bye.